Alright, in this video we're going to talk about the inverse cosine function, and we're going to approach it pretty much the same way we did the inverse sine function in the last video. So here we have the graph of the cosine function, and we're going to want to use it to get the graph of the inverse cosine function. Okay, but the problem is this graph of the cosine function fails the horizontal line test. Okay, so for example, if we draw a horizontal line at y equals 1/2, that line is going to hit the graph at 1, 2, 3, 4, 5, 6 points that we could see, really infinitely many points out this way and out that way. So this graph does fail the horizontal line test, but what we can do is restrict the domain of the cosine function to 0, pi. So if we do that, we're going to end up with this, and let's zoom in on that a bit. So so this is a zoomed in look at the graph of the cosine function from 0 to pi. So this is 0, 1, and then down here we have pi, -1. So this graph does pass the horizontal line test, because any horizontal line that we draw is going to intersect it at most once. So horizontal lines up here, way down here, are going to hit the graph 0 times, which is fine. Or horizontal lines in here, they're going to hit the graph once, and that's fine. So since this graph passes the horizontal line test, this restricted cosine function does have an inverse. So remember, if you have a graph of a function and you want to get the graph of the inverse, you take the graph of your function and reflect it over the line y equals x. So here's the line y equals x. Here's that same graph we were just looking at, just zoomed out a little bit now. So this is 0, 1, all the way down to pi, -1 here. Here's the line y equals x. So if we take this function and reflect it over the line y equals x, we're going to have something that kind of sort of looks like this. Okay, so let's just look at that by itself, and that's what we have here. So this right here, this right here is the point 1, 0. And this up here is the point -1, pi. Okay, so the graph of the inverse cosine function goes from -1, pi all the way down to 1, 0. And just like with the inverse sine function, this is it. This is the entire graph, because back in the beginning we had to restrict the domain of the cosine function to just this part here. Okay? And so since we did that, then our inverse cosine function is just this here. That's the entire thing right there. Okay? So let's talk about some of the properties and how it relates to the cosine function. Okay, so first of all, the domain, as we just saw in the graph, is from -1 to 1, and the range is from 0 to pi. Okay, so when you evaluate inverse cosine functions, you're always going to get something positive or 0. In other words, never something negative. So when you evaluate the inverse cosine function at any value in the domain here, you're always going to get something that's not negative. So it's either 0 or positive, so it's a good thing to keep in mind. Some notation, y equals cosine -1 exponent up there, so cosine inverse of x, or inverse cosine of x. Same thing as saying y equals arc cos of x, arc cosine. And short for arc cosine is a cos, y equals a cos of x. So this isn't really common, not as much as it used to be anyway, because it depends on where you are though. Anyway, that's just 3 different ways of saying exactly the same thing, just the inverse cosine of x. So 3 different ways of saying it. And here's some properties relating it to the cosine function. So the inverse cosine of the cosine of x equals x if x is between 0 and pi. Okay. So here, as long as x is between 0 and pi, you have this nice cancellation property here. So remember, functions and their inverse functions, they have that nice property where they cancel each other out. But here, because we restricted the domain of cosine, in order to do this, we have to have this restriction here. Okay? So that's why when we evaluate cosine of x and then do the inverse cosine, x has to be between 0 and pi in order for us to cancel like this. What if x is not between 0 and pi? Then how do we do this? We will talk about that in a later video. And similarly, cosine of the inverse cosine of x equals x if -1 is less than or equal to x is less than or equal to 1. So as long as x is between -1 and 1, then we can we have this nice cancellation property here. What if x is not between -1 and 1? Then we just cannot do this at all. Okay, we just can't do this at all. And the reason is that, remember, the domain of the inverse cosine function is from -1 to 1. So here, with this cancellation property, first we do inverse cosine of x and then cosine of the result. Okay? But if x is not between -1 and 1, it doesn't even make sense to say this, so we just can't do it. There's no solution, it doesn't exist, we just can't do it. So that's why x has to be between -1 and 1 in order for us to do this here. Okay, and remember, that's not what's going on up here. Up here, we can still do it. We can still do this one. We can still evaluate this inverse cosine of x even if x is not between 0 and pi, but we just can't use the cancellation property. So little distinction there. It's really pretty much almost the same thing that's going on in the inverse sine function. Really, it is the same thing. So that's pretty much it. Just one more thing to point out with notation. So this cosine inverse of x with this -1 in the exponents, just like with the inverse sine function, we want to be careful. This is not the same thing as 1 over cosine. So typically this -1 in the exponent means a reciprocal, something like that. Cosine of the -1 of x, really this is read cosine inverse of x or inverse cosine of x. It's not the same thing. It's not equal to 1 over cosine of x. Okay, 1 over cosine of x is the secant of x. The secant of x is not equal to the inverse cosine. Okay. This notation just comes from, if you have a function f of x, then the inverse function is denoted like this. Okay. So the function is cosine, the inverse function is denoted like that, cosine inverse, -1 in the exponent there. So that's it for the inverse cosine function. The other inverse trig functions coming up in the next few videos, along with some properties and some examples of evaluating them.